Okay, so I want to go ahead and discuss 7-2 parallel lines and proportional parts. So before we talk about this theorem here, I'm going to go ahead and draw a figure for you. We have a triangle where we have a segment that is parallel to this side over here. And we're going to label this A, B, C, D, E. And we're going to make note that segment BC is parallel to segment DE. Okay? So now that I have this figure, let's go ahead and discuss the triangle proportionality theorem, which states that if a line is parallel to one side of a triangle and that same segment or that line intersects the other two sides, then it's going to divide those sides proportionally. Meaning that, hey, I can take this part over this part and create that as a ratio and equal that to this part over this part. So let me go ahead and write that. We have this part, so it's AB over BD, and I equal that to AC over CE. Okay? So whenever you see from the beginning that you have these parallel lines, it's going to divide those sides, these other sides, proportionally. Okay, so let's go ahead and take a look at example 1 here. In triangle PQR, segment ST is parallel to segment RQ. So these two segments here are parallel from the beginning. If PT is 7.5 and TQ is 3, SR is 2.5, let's go ahead and find PS. Now, PS, we are trying to find what PS is, so I'm just going to make our lives, simple and call PS X, because that's basically our unknown. So we're going to say, let PS be X. So if PS is X, I can call this segment here X, okay? Now, remember, again, we have these segments parallel to each other where this segment intersects these sides here, meaning that we can create a ratio between these two parts and set that equal to these two parts, just like what we had at the beginning. So I say X over 2.5, and I equal that to, well, since X is in the numerator and it's close to that 7.5, I need to be very, very consistent. So I need to put 7.5 instead of 3 up top, so 7.5 over 3, okay? Then look at that. We have two ratios that equal to each other. So, cross multiply, you get 3x equals 7.5 times 2.5, and 3x is equal to 18.75, and then if I divide both sides by 3, x is 6.25, and since we called PSX, and x is 6.25, then we can safely say that PS, the segment itself, is 6.25. And that is your answer. That is your answer. Okay? Okay, so let's go ahead and take a look at B. B says that if SP is 8, so if SP is 8 and RP, ooh, look at that. So here's R, and this is P. So this whole thing here, y'all, that is 10. RP is 10. And then PQ, ooh, this whole thing here is 5. We're going to go ahead and find TQ. So again, we're going to say, let TQ equals X. Let TQ be X. Yeah? Okay, so let's start with something basic. I'm going to go ahead and look at this left-hand side of the triangle. So I have 8, and I have this part, and this whole thing here is 10. Let's think logically. If this whole thing here is 10, and I have 8, what's left over? 8 plus what will give me 10? Do your algebra. Well, that's going to give you 2, right? So 8 plus 2 is 10. This is using what we call the segment addition postulate where, it's part plus part is equal to a whole, right? So this part plus this part is equal to the whole thing. So segment addition postulate. If you're having troubles with that, again, it's part plus part equals a whole. Given that one of the part is 8 and the whole thing is 10, you want to solve for that other part just like you would in algebra. Sorry, I need to put the equal sign there. So it's part equals 2, okay? So the part is equal to 2. So we already figured out that, and we really need to figure out what this part here is and also this part here is to create that ratio. Now I got to do the same thing for this other side. I really need to figure out what this part here is, right? Without that part, I can't create my ratio. Notice the fact that we have x here and this whole thing is 5. Again, use that part plus part is equal to a whole. Okay, so we have part plus part equals whole. One of the parts is x, and the other part is our unknown. We're going to call that just part. And I equal that to the whole thing there, 5, right? This is my whole thing. So solving for that part, I need to minus the x on both sides because I just want to isolate the word part on the left-hand side of the equation. So part is equal to 5 minus x. So this is the part that I'm trying to figure out, and that's 5 minus x. So it's 5 minus x, okay? So now, I'm going to real quickly erase this. And I want to go ahead and confirm with y'all that if I do this part plus this part, it should give me that 5, right? So 5 minus x is equal to, oops, sorry. Let's try again. It's 5 minus x plus x equals 5, okay? I just want to see the left-hand side is equal to the right-hand side. Negative x plus x. You can combine those terms there, right? Because negative x plus x, they cancel each other out. So what am I left with? The 5, just for the left-hand side, is equal to, what's the right-hand side? It's just 5, right? So 5 is equal to 5. The left-hand side is equal to the right-hand side. So good, you can safely say that 5 minus x does work for this part, okay? So that's how you figure out that type of, scenario here. And great, now, again, this segment is parallel to this segment of this triangle here. So I can go ahead and create a ratio between these two parts and equal to these two parts. So 8 over 2 equals 5 minus x over x. Cross multiply. Should use a different color for this one. You should get 8x equals, 2 times 5 minus x, 2 times the quantity, 5 minus x. So 8x is equal to 10 minus 2x. Great, I need to get, the x's on one side and just that number on the other side. So I should add both sides by 2x. So 10x is equal to 10. Y'all, that's really easy. X is equal to 1. So x is equal to 1, right? So if x is equal to 1 and we let TQ be x, so TQ should also be 1. TQ should also be 1. That's your answer. Example 2. In triangle DEF, EH is 3, HF is 9. So let's go ahead and write those things down. So EH is 3 and HF is 9. And notice that this says DG is 1/3. So DG is 1/3 of GF. So I don't see a GF here, or anywhere in this problem or in this from the question. What the heck is GF? Well, if we don't know what GF is, if it doesn't state it, then we're just going to call it the unknown. We call that our x. So let GF be x. Now, if GF is x, that means I can rewrite DG as 1/3 of x. Okay? So GF is x, and I'm just replacing that with the variable x. So dg is 1/3 of x. So dg is here. I can say that's 1/3 x, and then gf is what we called x. Okay? Now, notice that the question here is asking you, is DE or segment DE parallel to segment GH? This is not parallel to begin with. We are trying to prove whether or not these segments are parallel. We are trying to figure out if these segments are parallel by using the triangle proportionality theorem converse, okay? So again, this figure here, we don't have parallel segments to begin with, but over here, we do. We are given the parallel segments, and we are able to work with creating the setup for this one, okay? So, in order for me to determine whether or not segment DE is parallel to segment GH, you have to say this. If these parts, so I'm taking this over this equals this over this, so if these parts are proportional, then we can say that segment DE is parallel to segment GH, okay? If these parts are proportional, then segment DE is parallel to segment GH, okay? So let's create a setup where I take these two parts and make it a ratio. So I have 1/3 x over x equal that to, well, since 1/3 x is what I put up top and it's next to that 3 there, I have to put that up top as well. So it's 3/9. So 3/9. Great, we have a proportion. I can cross multiply. X times 3, or 3x, is equal to 1/3 x times 9. Okay? So I have 3x, and I equal that to, okay, so multiplying this, that's simple. We just ask, okay, 1/3 times 9. Or I can say, what's 1/3 of 9? We put that in our calculator, or we think about it. 1/3 of 9 is basically 3. And I slap on that x there. So are these two ratios proportional? Well, as you can see here, the left-hand side is equal to the right-hand side. So if the left-hand side is equal to the right-hand side, then yes, we can say that these parts here are proportional to each other. And if those parts are proportional to each other, then we can safely say that yes, segment DE is parallel to segment GH. Okay? So this was just me using the converse of the triangle proportionality theorem. Over here, we said that the triangle, the converse of the triangle proportionality theorem, and here this is the triangle proportionality theorem. So the triangle proportionality theorem is basically our if P then Q, and the converse is our if Q then P, okay? Again, with the triangle proportionality theorem, the parallel segments are there to begin with. For the converse of the triangle proportionality theorem, you will say that you are proving whether or not the segments are parallel. The parallel lines or the parallel segments are not there to begin with, okay? All right, let's go ahead and move onto the mid-segment of the triangle. So the mid-segment of the triangle, which we've already covered back in semester 1, it's a segment that joins the midpoint of two sides of a triangle. Okay, so let me go ahead and draw a triangle for you all. So I have a mid-segment over here. Okay, so we're gonna call this X, Y, Z, and then here's W, V. If this is the mid-segment and this is the midpoint here, that's going to split this segment into two congruent parts. So I draw a tick mark here and a tick mark here due to the fact that we have a mid-segment, which results in having midpoints here and here. Okay, so since that, I'm gonna go ahead and draw the midpoint there. And if this is the midpoint of XV, that means we're gonna have two tick marks here and two tick marks there. Okay, and note that YZ, or segment YZ, is the mid-segment of this triangle. Okay, so here's the triangle mid-segment theorem. A mid-segment of a triangle is parallel to the third side. Okay, so this is parallel to this third side, and that mid-segment is half as long as the third side. So again, this is parallel to this. So using picture above, this picture here, we can say that segment YZ is parallel to segment WV. So the mid-segment is parallel to the third side here. So here's the mid-segment, and then this is the third side. And know that the mid-segment is equal to 1/2 the third side. So 1/2 the third side. So since YZ is the mid-segment, so YZ is the mid-segment, that is equal to 1/2 the third side, which is WV. Okay, and I don't really think we need to put the parentheses there, but 1/2 WV. Okay, so now I'm going to go ahead and move on to the second page of the notes. Alrighty, on to the next page, example 3 in the figure. Segment XY and segment XZ are mid-segments of triangle RST. Find each measure. Okay, so we know that XY is a mid-segment, and know that a mid-segment of a triangle, it's parallel to the third side. So here's XY, and it's parallel to, let's say, ST. So this is parallel to that. Okay? And then XZ is also a mid-segment, and it's parallel to RT. So I'm going to draw double arrows to show that they are parallel. Okay? So to find XZ, okay, to find XZ, know that it's parallel to RT. So if XZ is equal to that third side, or RT, oh, sorry, no. If XZ is equal to 1/2 of the third side, or RT, we know that RT, as you can see here, is 13. So RT is 13. Okay? So I'm going to go ahead and replace RT with 13. And then I'm going to basically simplify. So XZ is 1/2 of 13. What's 1/2 of 13? That's going to be 6.5. This is my answer. Okay? And then let's go ahead and find ST. So ST is parallel to XY. So again, I'm going to do this again. So XY is my midsegment, which is equal to 1/2 of ST. So then I'm going to solve for ST. This is what I want to get by itself. Know that XY is 7. Okay? So then I'm going to replace XY with 7. And I'm going to equal that to 1/2 of ST. And again, I'm solving for ST. So how do I get ST by itself? Well, I have this 1/2, which I'm going to rewrite as ST over 2, right? Because 1/2 times ST is the same thing as ST over 2. So since I want to get rid of this 2 that's in the denominator of this fraction, I need to multiply both sides by 2. So multiply this by 2, and I'll multiply that by 2. So 2 times 7 is 14, and then these two 2's, they cancel out. So that's going to give me ST. Okay, so ST is 14. ST is 14. Okay? Alright, now, what is the measure angle RX? Oh, sorry, no, not RXY. It's RYX. So I need to find what RYX is. Okay? So if we know that this is 124, how long is this angle here? Okay? Okay, well, know that we have parallel lines, and this is going to be our transversal. Okay? That means that if this here is 124, so I'm going to go ahead and use my little color here. And we know that this is 124. This angle here is congruent to this angle due to the fact that they are alternate interior angles, okay? So this is equal to 100 in, so I'm going to write this. Measure angle RYX is 124 degrees by the alternate interior angles. Okay, so that's the measure angle RYX. Now I'm going to go ahead and look at these two theorems or properties or whatever. We have the congruent parts of parallel lines and the proportional parts of parallel lines theorems. I'm going to start off with this one, and then I'm going to get into this one after I talk about this. So, alright, if 3 or more parallel lines intersect two transversals, then they cut off the transversals proportionally. So suppose that I have, let's say, these two transversals here, and I have these 3 parallel lines. So here's an arrow, and here's an arrow. I'm going to go ahead and label some stuff. So I can see that there's a point here, here, and here. So let's label them. I'm going to call this X. I'm going to call this Y. I'm going to call that Z. So point here, and a point here. And I'm going to call this R, S, and T. Okay? So one more time. If 3 or more parallel lines intersect two transversals, then they cut off the transversals proportionally. So I can basically take this part over this part and set that equal to this part over this part. Okay? So let's go ahead and write something here. If we know, so if segment XR is parallel to segment YS, which is also parallel to segment ZY, t. Then we can take this part over this part. So that's xy over yz. And I'm going to set that equal to this part over this part. Okay, so that's rs over st. Okay, this is the proportional parts of parallel lines. Alrighty, let's go ahead and go back to the congruent parts of parallel lines, which states that if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So this here that we drew before, let me go ahead and redraw that. So I have 2 transversals and these 3 parallel lines, okay? And we're going to call this again x, this is y, this is z, and then here's r, here's s, and then here's t. The difference between these 2 theorems here is that if you see a tick mark here and a tick mark here, okay, that means that these segments are congruent. So if you have these 3 parallel lines and you see these 2 segments congruent, that means that these 2 segments are congruent as well. But in fact, we're going to go ahead and draw 2 tick marks there. So we say that if segment XR is parallel to segment YS and it's parallel to ZT, and segment XY is congruent to segment YZ, then segment RS is congruent to segment ST. Okay? So now we've already talked about congruent parts of parallel lines, and we've already talked about proportional parts of parallel lines. Let's go ahead and take a look at this example here. Example number 4, find x and y. Know that we have these 3 parallel lines, and we see those 2 tick marks there. That means that using the congruent parts of parallel lines theorem, that means that these segments here are congruent. Okay, so let's go ahead and find x and y. I'm going to start off with finding y. So finding y. I know that these segments here are congruent. So 3y plus 8 is equal to 5y minus 7. Then I'm going to do my basic algebra. I get what's 8 plus 7? That's 15. And I set that equal to 2y because I'm subtracting both sides by 3y here. So 15 divided by 2 is 7.5. That's the value of y. Okay? Now I'm going to go ahead and find x. So know that these 2 segments are congruent. So 6x minus 5 is equal to 4x plus 3. So 2x is equal to 8. X is equal to 4. And then I'm done.